Hello and welcome to video 31 in my Rigging in Maya series. We now only have a few more areas to rig on this dog, and then we can move on to the skin weights and adding support for the root control. First, let's move back to the legs and add in the paw controls, and these will be a mixture of FK and IK controls. In this first video we will focus on setting up the foot and then adding the foot roll and bank functionality, using nodes rather than set-driven keys to give us maximum efficiency and flexibility. We will then continue the setup in the next video, adding more controls for the animator, plus some extra configuration options for us to use while setting up the rig. Before we start work, I wanted to ask you something. Are you enjoying these videos, and would you like to see more? Well, if so, there are a number of ways you can help support future content. The first is to simply head over to my Ko-fi page and treat me to a coffee to say thank you. The second is to head over to the antCGi store. Here you can download the assets for each of my courses, but don't worry, there are plenty of free downloads available too. The third way you can help is to join the antCGi club. Membership starts from as little as 99p a month, and in return you can earn yourself some exclusive rewards. These include member-only videos, a limited edition antCGi pin badge, and a discount on all antCGi merchandise. There are a few ways you can join. The first is to simply click the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon or Ko-fi pages and become a member there. So there you go, the future of this channel and its contents is in your hands. To get more information on how you can help, follow the link on the screen or in the description below. So here we are again with our dog rig. Now, I've done a few updates since the last video, but these are simple things that you should be able to add yourself, especially if you've been following along with the series so far. Let's focus on the rear paw for now. This control is new, and what this will do is make the foot roll and bank more interactive, so the animator can move this rather than adjusting sliders in the channel box. I do think that making a rig more interactive can make it easier and more fun for the animators to use. So if they move it forwards and backwards, the paw will roll onto the ball and up onto the toe, and then back onto the heel. Side to side will make the paw rock left and right. I've also added a series of extra attributes to the main leg control. We will be wiring these up in the next video to give the animator even more control. So we can get more functionality out of the paw, I've also updated the IK and FK skeletons. Let's set this to be halfway so we can see both. And move the IK paw up. So you can see that I've also included the toe joints in the IK and FK skeletons too. And these are set up the same way as the legs, so they blend between both sets of controls. Let's hide some of this so we can see them. There we go. So the main skinned joints here are constrained using a parent constraint. So they move between the IK toes and the FK toes. So the same as the rest of the leg. With the IK toes, you will notice we have an extra joint here. This is because we are going to be using IK, so we need an end joint to help set this up. We also have this extra paw joint too. This is just parented to the main metacarpus joint, and again, because we are using IK, this will help to keep the paw steady. You can see the hierarchy here. I've also set up the FK controls already too. Again, this is just a case of using parent constraints to make the joints follow the controls. Nothing complicated about that. If we adjust them, you can see the main skin joints above moving too. So you see, everything blends. Let's reset this. There's one other addition. Here, parented to the main leg control are two groups and a series of joints. Let's make this visible. So what we have here is a standard reverse foot setup. We also have two groups which are either side of it. These will be used to add the foot bank functionality, something like this. So they should sit outside and inside each paw. You see, we can rock the paw using this rotation. The joint hierarchy is set up in reverse. This is why it's called a reverse foot. And it's set up like this so we can easily pose the paw. If you want to learn more about this reverse foot setup, then please check out the video on the screen now. The idea is we can use a heel joint to move the whole paw. The tip will make the paw move onto its toes, and the ball to bend the toes and raise the heel. Again, these are all basic additions, so go back and revisit video 7 for a more in-depth overview of this setup. These are just parented to the leg control, so it will move with the paw. Okay, so with those set up and ready, let's start adding the main controls. We are just going to focus on the IK leg from here on, so here we have the IK joints. What we need to do first is create a series of IK handles. So what we need are simple single chain solvers. Create the first from the metacarpus to the main paw joint. Here it is, and let's rename it. I'm going to press Y to reactivate the last tool and then create an IK handle for each toe section. And let's also rename them to match the toe joints. Okay, so we have all the IK handles now. The problem we have is each one has a transform applied to them. We need these to be clear, so all set to 0, so we can have more control over them. The easiest way to do this would be to use an offset group. That is, if you're using a version of Maya earlier than 2020. Obviously, Autodesk introduced a lot of offset parent matrix attributes and other tools with Maya 2020, but we're not going to get into that in this particular course. If you do want to know more about the offset parent matrix attributes, check out the video that's on the screen now. Okay, so let's press Ctrl and G to create an empty group and match its transforms to the joint. So that's now in the same position and orientation as the joint. Let's rename the group, adding offset to the end. Now parent the IK handle to the group. You see, the transforms are now back to 0. What we need to do now is create an offset group for the rest of the IK handles. You don't need one for the main paw IK handle though. Just focus on the toes. Now even I think this is a tedious task, so it's times like these when scripting comes in handy. So I'm going to use a bit of code to do all the hard work for me. Now don't worry, this bit of code, along with some of the others that I'm going to be using in the next video, will all be available to download as part of the source files. There we go, all done. And all the IK handles have nice, clear transforms. Okay, let's bring some things back. Hide the model again. So we need to parent these to the main leg control now. So select these and the control and press P. They all move with the control now. But what's nice is if we move the control away from the leg, so down like this, the toes orient themselves to follow it. So we get a nice natural peel effect. Let's change the background colour. It's a bit difficult to see with these joint colours. Just pressing Alt and B will cycle through some different variations. That's a bit brighter, not ideal, but you can see the joints a bit better now. So you see the paw rotates and the toes all point to follow the control. This is why we added that extra paw joint at the base, to help keep the paw steady. Speaking of which, Now we're using the IK to control the metacarpus. We need to remove the orient constraint we added previously. We just don't need it anymore because the IK is now taking care of the rotation. Let's find the joint and delete this constraint. OK, done. Right, now we need to make the IK handles follow the reverse foot joints, just so we can pose the paw. Let's find it and make it visible. Maybe change the background again. Actually, it was OK where it was. So here we have the main locator, which helps with the leg's stretchiness, and the driver IK handle, which is the one that controls the leg. These are currently parented to the leg control, which is fine, but we need them to follow the ankle joint instead, rather than the whole foot. So as the paw rolls, the leg will follow. So all we need to do is move these. Let's hide the IK joints for now. So these are currently parented to the control here. We want to move them so they are under the ankle reverse joint or the metacarpus reverse joint. Those are parented to this joint now. If I rotate the reverse foot's ball joint, the IK handle and stretch locator follow, which means the rest of the leg will follow too, and the knees will bend. If I bring back the joints, you can see it a little bit clearer. Now let's look at the other IK handles. Select all the tip offset groups. These are the ones at the ball of the paw, and parent them to the reverse ball joint. OK, good. They follow now. One thing to point out about the reverse foot when you're building yours: make sure the ball joint lines up with these joints here, so everything pivots around the correct point. Finally, the end IK handle offset groups are parented to the reverse tip joint. So now we can rotate the tip and the whole paw follows. We have one more IK handle to move, so parent the main paw IK handle to the reverse ankle or metacarpus joint. Now when I rotate the reverse heel, we have full control over the paw, which means we can still control everything with the main control. And the joints still follow when we move it away, like this. What this setup will allow us to do is use the reverse foot joints to pose the paw. So we can control the ball of the paw and the tip to move it onto its toes. We can also twist from the tip and the heel. What we can also do is move the IK handles around. This will give us even more control over each toe, so we can essentially pose them later on. We can also do it with the end joints too. If we go back to the two main groups again, you see we can use these to bank or tilt the paw. We can do it inwards and outwards. So there, we have all the systems in place now. So let's make this control drive them. If you want more direct control over the toes, so you can rotate them rather than using translations as we will be doing, you could use an additional offset group, like I have in this example. We have an additional rotation group between the IK handle and the offset group. Both of these groups need to have their translations matched to the previous joint though, which is important. You can then use the rotation group as the main control group. This way you will get a nicer rotation, but if you use this setup, remember to use rotations, not the translations, as we will be doing in the next video. Now don't worry about connecting them now. Like I said, we will be covering that in the next video, but feel free to use whichever setup suits you or your rig. Okay, so I've adjusted the colours so we can see the joints a bit clearer. I just added them to some display layers. So what we're going to do now is make this control pose the paw, so we get a nice foot roll. Traditionally, this would be set up using set-driven keys, which define a set of poses which the reverse foot moves between. The problem with this setup is it's not very economical, plus the poses are then set in stone. The only way to adjust them is through the graph editor, so it's not very intuitive. What we are going to do is use nodes instead, and what this will allow us to do is add in more functionality, so the paw, or if you're working on a foot, can be configured to suit that particular character. Imagine you're walking forwards. The first stage your foot goes to is to move onto the ball, rotating it so the heel raises off the floor. Something like this. So let's add this in first. Open the node editor and bring in the reverse ball joint and also the paw control. Let's organise these. It looks like we need the Z translation and the X rotation. So connect Translate Z to rotate X. Now if we move the control, the ball rotates. Perfect, that was easy. The ball joint is moving, yes, but not very much, so let's increase the amount it rotates. Create a multiply divide node and rename it to left, rear, paw, roll, multi. Open these and connect Translate Z from the control to input 1x and then output X to the rotate X attribute. We can delete this now. So at the moment, input 1x is being multiplied by input 2x, so by 1. Let's increase this to 10. Now if we move the control, the ball rotates a lot more. Okay, so now we need to decide at what point will the foot then move up onto the tips of its toes. Let's set this to 4. So this pose looks good for now. At this stage, we need the tip joint to start moving, but we also need the ball joint to roll backwards, so the foot is straightened when it's on its toes. Let's continue working on the ball first and get it to stop moving once the control reaches 4. Create a condition node and call it left paw rear roll condition. Open these. Let's look in the attribute editor too. We need to know where the paw control is, so connect Translate Z to first term. Also set second term to 4 because this is the value we need to check for. Remember, this is going to be the translation of the control. Now change operation to less than because we need to know when the control Z translation is less than 4. If it is, the ball should roll. If not, then it should stop. So if the ball is supposed to be rolling, we need to use the colour if true value here. This is the rotation amount. So connect output X from the rear roll multinode to colour if true R. We can see that the rotation at this point is 40. So when the ball needs to stop rotating, it will switch to the colour if false value below this. We need to set this to 40, otherwise the ball will just snap back to its first position. Now connect outColor R to rotate X on the ball reverse joint. And delete this. If we move the control now, as soon as the Z translate value goes past 4, the ball stops moving and stays at 40. Okay, so the next step is to tell the ball to instead roll backwards rather than just staying in this position. Create a plus minus average node and call it left paw rear roll reverse PMA. We need to add some inputs now. Connect output X from the roll multinode to input 1D0 and also connect it to input 1D1. You see, connecting it has now produced these two inputs. Delete the connection to input 1D0. The first input's value should now be the rotation value where the ball joint stops moving, so this needs to be 40. Change operation to subtract. What this will do is take 40 away from the current rotation value. Let's set the control's translation back to 4, the point where the ball stops moving. So these are both 40 now. Next we need another plus minus average node. So duplicate this one and update the name, changing reverse to subtract. Make sure input 1D0 is still set to 40. Take output 1D from the reverse plus minus average node and connect it to input 1D1. That's this value here, which is 0 because we are currently taking 40 away from 40. Let's move some of these around. Now connect output 1D from the subtract plus minus average node to colour if false R on the condition node. We're essentially replacing that static value of 40 which made the ball joint stop moving. Let's copy this tab and test this. That's right, we need the operation on the subtract plus minus average node to be set to sum. Okay, so let's test this again. So now as the control moves past 4, the ball joint stops and then goes into reverse. Perfect. Okay, that's the ball set up, so let's now get the tip moving. Let's close this. We need another multiply divide node, so just copy this one and rename it to left paw rear roll tip multi. Take output 1D from the reverse plus minus average node and connect that to the roll tip multi node's input 1x attribute. Let's go back to the main condition node again. So what we can do is use the same condition node we are using for the ball rotation, but this time use the G column here. Instead, we can say that if the second term is less than 4, do nothing, but if it goes over 4, start to rotate the tip joint. Connect output X to colour if false G. And make sure colour if true G is set to 0, so the tip doesn't move. Next, set input 2x to -1 because we want the tip to rotate the opposite way. Bring the tip reverse joint into the node editor and connect outColor G from the condition node to its rotate x attribute. Okay, let's try this now. So the foot goes back onto the ball and back down, then up onto the ball and onto the tips of the toes, or the claws in this case. Good, that works. On to the next step. As we move the control back, the ball rotates back down. The problem is it doesn't stop, so it continues moving, and this will just end up compressing the heel. So we need to stop it when it gets to the right point. We can use another condition node to do this. Let's just organise this a bit and duplicate this condition node, open it, rename it to left paw rear roll clamp condition. we need the main role multinode here so we can check where the control is. Connect output X to first term. So here we have the main rotation value. We want to check when the control is moving backwards, so when the control goes into negative figures. So set second term to 0 so we can see when its translations are less than 0. Now set colour if true R to 0, so the joint will ultimately stay set at 0. Next, connect the rear roll multinode's output X attribute to colour if false R. So if the control is a positive figure, use the main rotation value. If not, set the joint's rotations to 0. Now connect this condition node to the original one. So out colour R is connected to colour if true R. Okay, so if we move forwards, that works. And if we move the control backwards, the ball stops moving. Perfect. Yep, that's moving really nicely. Okay, now the next step. The ball now stops when the control moves backwards. So now let's use the same control to get the paw tipping back onto the heel. And this is pretty straightforward. We need another condition node. Let's call this left paw rear roll heel condition. These names just get longer and longer. And open it in the attribute editor. Again, we need the main control's translation value. So take output X from the roll multinode and connect that to first term. We can leave second term set to 0 because we need to know when the control is going into negative figures. And operation set to less than. Now also connect output X from the roll multinode to colour if true R. So if the control is heading backwards, use this value to drive the heel joint. Colour if false R needs to be set to 0 so the heel won't move if the control is moving forwards. Bring the reverse heel joint into the node editor. Move these around. Connect out colour R to its rotate X attribute. Okay, so that should be the foot roll set up. Let's give it one more try. Okay, perfect. So we can use a single control now to move the paw from back on its heel right up onto the tips of its toes. And it's this setup that will make creating walk and run cycles so much easier for the animator. That's the foot roll setup, so now let's add in the foot bank functionality. We have the foot roll setup which uses the control's Z translation. What we're going to do now is use the X translation to drive the foot bank, well, the paw bank. I keep saying foot, but you know what I mean. As you can see, I've already brought in the main groups and the control into the node editor. So we can use the outer group to bank this way, and the inner group to bank this way. So we need to check which way the control is moving and then trigger the correct group's rotation. We can just use another condition node to do this. So let's create one and call it left paw rear condition. And open it in the attribute editor. We need the main control's translate X value, so connect that to the first term and change operation to greater than. So this will check when the first term goes above 0, but we can also use it to check when it goes below 0 too. If it's greater than 0, we can use the colour if true R value here. So connect translate X to colour if true R and set colour if false R to 0. Now connect out colour R to the outer group's rotate Z attribute. With the inner group, we can use the same condition node, but instead use the next column along, which is the G column. So if the first term isn't greater than 0, but it is less than, it will output the colour if false G attribute. So let's connect translate X to that. There we go, that's set up. Now connect antCGi to the inner group's rotate Z attribute. Okay, let's try this. So the groups are moving but in the wrong direction, plus they aren't moving enough. So we can use a multiply divide node to fix both of these issues. Let's create one and call it left paw rear bank multi. Connect translate X to input 1X and output X goes into colour if true R and also colour if false G. So the translations are now being piped through the multiply divide node. Okay, so to make the groups rotate the opposite way, the input 2x value needs to be a negative one. So set this to -1. So that works now, but while we're here, let's adjust the value so the paw banks more. So let's use -5. Okay, much better. And we now have a paw which banks and rolls just by moving a single control. So that's the first part of the paw setup complete. In the next video we will continue working on it to add in more options for the animator and also configuration options so we can adjust how the foot roll and bank works. Okay, another video over. I hope you enjoyed it and learned something new. Thanks for watching right to the end, and remember to hit that like button and also subscribe to keep up to date with future videos. If you have any questions or suggestions, please post them in the comments below, or alternatively, why not join the antCGi community Discord group, where me or other members of the community will be more than happy to help. Remember, to help support future content and keep these videos free, please visit the antCGi store or join the antCGi club. Alternatively, if you would just like to show your appreciation for these videos, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again for watching. This is antCGi signing off, and I will see you on the next one.